Okay, in this section, we are doing first order linear differential equations, and these differential equations have a standard form. So if they are not in the standard form, we need to put them in the standard form, and then we're going to find an integrating factor that's going to help us solve the differential equation. Okay, so the first order linear ordinary differential, oh, it doesn't have to necessarily be linear. First order differential equation in standard form is, oh yeah, it does have to be linear. It's linear. Dy dx plus p of x, y of x is equal to q of x. Okay, so that means I have the derivative is equal to derivative plus something times itself is equal to another function q of x. Okay, and so in order to solve this problem, we have to get an integration factor. Okay, so we're going to use the fundamental theorem of calculus, part 1, in order to be able to get this integration factor. So let's derive v, which is going to seem like, what in the world is she doing? But once we figure out what v is, then life becomes simple. Okay, so let me see if there was anything I wanted to say. Nope, I just want to go ahead and derive v. Okay. All right, so we already know from the fundamental theorem of calculus, if you take the derivative of a function that looks like that is the integral of a to x of f of t dt, you just get f of x. Okay, so I remember these on Calc 1 exams. I would put some hideous function in for f of t, and all you had to do was change the t's for x's. That's it. That was the only thing you had to do. Okay, so what I want to do is I want to consider this. So let's consider the derivative with respect to x of y of x times e to the integral of x p of t dt. So we're going to take the derivative of that. So why in the world do I want to do that? Okay, well, here we go. So derivative, the first is y prime times the second, which is e to the integral of x times p of t dt, plus the first, which is y. And then the derivative of the second, well, whenever you take the derivative of an exponential function of u, remember you have to multiply by the derivative of the exponential function. So that becomes the derivative with respect to x of the integral to x of p of t dt. So that's the derivative of the exponent part. And then I have to multiply by e to the integral of p of t dt. Okay. So now I have that. All right. So I am going to let this thing be my v of x. So this is v of x, and this is v of x. But notice the derivative of x of the integral of x, this thing just becomes p of x. Okay, so now I get the derivative with respect to x of y of x times v of x is y prime of x times v of x plus y of x p of x times v of x. So that's what that line becomes. Okay. So let's go back to the original differential equation. it was dy dx plus p of x, y of x is equal to q of x. And we want to multiply this whole thing by v of x. So if we multiply this whole thing by v of x, we get dy dx times v of x plus p of x, y of x times v of x is equal to q of x times v of x. But I just showed that this thing, which appears right here, is that on the left. So this just becomes the derivative with respect to x of y of x times v of x is equal to q of x times v of x. So let's integrate both sides, and we get y of x times v of x is the integral of q of x times v of x dx plus a constant. So there we are. There's the solution. Y of x, the integral to x of q of x, v of x dx plus a constant, that whole thing divided by v of x. So that is the solution to the differential equation. Okay. That's the solution to the differential equation. Okay, so let's go through a little exercise where we're going to only identify what P and Q are. I'm not doing anything else yet. We're going to eventually figure out how to find V. Oh, that's the wrong thing. So we want to go through an exercise. We identify P of X and Q of X. All right, so here we go. Now I want some class participation on this. All right, so I'm giving you the standard form again. Dy dx plus P of X, Y of X. Actually, most people just write P of X, Y. Okay, so in this one, what is P of X? And what is Q of X? I need class participation. P of X and Q of X.
2xy.
Okay. Who is that?
It's Johnny.
Johnny. Okay. We're only going to keep the 2x, not the y. Okay, so this is 2x. And what's Q of X?
3x.
3x squared, sin x squared.
Yep, it's the whole thing. So it's 3x squared sine of x. Okay, any questions? All right, the next one. It doesn't look like something I'm ready to work with. I will fix it. Dy dx minus 1 over 4y is equal to cosine x. Sometimes they're not obvious. So what is P of x?
1/4.
Okay, so P of X is -1/4. And Q of X,
Cosine X.
cosine X. Okay, the next one. This one requires rewriting. We need to make it y prime plus 2 over x, y is equal to the tangent of x over x. So now P of X and Q of X.
Oh, 2x. 2/x.
2 over X.
And then
Go ahead.
tan.
Okay, you have to be able to put it in standard form and identify P of X and Q of X. Okay. Any questions? I think I did those in the wrong color. P of X was blue and Q of X was green.
Dr. Lott, anytime we mention the P of X, why do we skip out the Y? Or is it because
Because
P
it's
of
P
X
of
and-
X times Y. It's P of X times Y. So the Y is not included in the P of X.
okay, that's
The Y is not included in the P of X. Do you see that?
What are we looking up again?
Okay, it's P of X times Y. So the Y just stays there. The thing in front of it is the P of X.
Send me a text.
I can't hear you. Okay, everybody okay with that? Got a lot of quiet people on the call, so I need you guys to perk up. Okay, so here we go. This is the technique. All right, here's the technique. First thing you're going to do is identify P and Q. We've been doing that. Integrate P. Usually P is something that is not difficult to integrate. When we integrate P, we're not going to keep the constant because the constant is just going to carry through the whole problem and then it'll be dropped out. So we don't need the constant. Then we're going to compute the integral of that P and take that thing and say e to whatever we got. That's now our V. So now we know what V is. Okay. Then we're going to compute Q times V and then take the integral of that, then divide by V, and we have a solution. Okay. Where's my first problem? Here it is. All right, so here's my problem. I need to identify P and Q. So it looks like I need to rewrite it just so I can see it. So I'm going to write dy dx plus 1 over x times y is equal to e to the x over x. Any questions? Okay, so identify your P of x and your Q of x. Everybody got a P of x and a Q of x?
Oh, 1/x is Q. I mean, it's P.
Okay,
And Q is X is e to the X divided by X.
okay. So that was first step. Second step, integrate P. Integral of P of x dx is the integral of 1 over x dx. That's the natural log of the absolute value of x. And as I said to you before, at this stage, we don't need the constant because the constant falls out of the problem, so we don't need it. We only need the constant at the end. Okay. They also told us x was positive, so I don't need that. So I'm just going to write the natural log of x. So that's the integral of p. All righty, here's the key. The integration factor, nu or v of x is e to the integral of what you got. So that's e to the natural log of x. Oh, how wonderful that is. They are inverse functions. So I just get x. Okay, 4. I need to compute the integral of q of x with v of x dx. So that's the integral. Q of x is e to the x over x. V of x is just x dx. So this becomes the integral of e to the x dx. And what is that? What is the integral of e to the x dx?
E to the x.
E to the x plus my constant. Okay. So 5 says y, the solution, is the integral of q of x, v of x. Oop, that does not look like a v. V of x dx plus, don't forget that constant. That's why I always write that constant out. Divided by v. So that is e to the x plus a constant divided by x. And we are done. Any questions about that?
Could you just scroll back up to the technique just so I can finish writing the steps?
This part right here?
Yeah,
No problem.
thank you. Okay, you're good.
Okay, anyone else? Okay. Problem number 2. Okay, it is not in standard form. Not in standard form. So we need to divide everything by x, and we get dy dx plus 2 over x times y is equal to 1 over x minus 1 over x squared. Okay. Questions?
No.
Okay. P of x. Prentice, what is it? Prentice, what is, oh, Rodney, go ahead. Give me an answer.
Is it 2 over x
2 over x. And then q of x.
is 1 over x minus 1 over x squared?
Good. Okay. 2. All right, I need the integral of p of x dx. Prentice, can you help me here? Hello? Hi there.
No, I'm sorry, got lost a little bit. Just type
Okay.
that.
Do you know where we are?
So we need the integral of p of x, right?
Yes. So we need the integral of 2 over x dx. Take the 2 out. Make your life easy. So now what's that integral?
To natural log of x.
Yes. Again, x is greater than 0, so we don't have to do anything. Okay. Now I can write that conveniently as the natural log of x squared using logarithm rules. Thank you, Prentice. Okay, now I know my v. It is e to the integral of p of x dx, which is e, and the integral of p of x dx is the natural log of x squared. Oh, again, I have a function and its inverse. So this just gives me x squared. Any questions? X squared is v. Okay. 4. I need to compute the integral of q of x with v of x dx. That's the integral. Q of x was 1 over x minus 1 over x squared multiplied by v of x, which is x squared dx. So that's the integral of x minus 1 dx. What do I get for that? That's an easy one. What's the integral?
0.
Devin? Did you answer the question?
Yeah, I was gonna guess and say 0.
Okay. I want you to find the antiderivative of x.
It's x squared over 2 minus x.
Okay. Devin,
Yeah,
you see that?
no.
Okay. 1/2 x squared. Got to use the power rule on x. 1/2 x squared. The integral of minus 1 is x. And then I get a constant.
Okay.
Okay. All right. So then we're done because y of x is that integral of p of x, q of x, q of x. V of x dx. Don't forget your constant. That whole thing divided by v. So my solution is y of x is 1/2 x squared minus x plus a constant, the whole thing divided by x squared. Okay? And that's the solution. Okay, any questions about this? I have a couple more examples of the differential equations. And I think after this, we completely change topics. All righty, I'll see you guys tomorrow.
Do you have office hours tomorrow